Let's talk about the benzoin condensation reaction, which you can see right on your screen here. Starting from two molecules of some aromatic aldehyde in the presence of potassium cyanide, we used to get this type of condensation products which are known as the benzoins. Okay. First thing first here, the first reactant, that is the benzaldehyde, which is actually a type of aromatic aldehyde, it lacks the alpha hydrogen atoms, you can see here. If we say that this is the carbonyl group and this position here is the alpha position, it is not having any hydrogens, right? The potassium cyanide is actually the reagent here in this reaction, and moreover I can say here that this whole reaction is nothing but it is actually some sort of self-condensation reaction, right? And moreover, because the starting aldehyde molecule lacks the alpha hydrogen atom, so aldol type of reaction is not at all possible here, right? Now after this brief overview, I want to talk about the mechanistic details of this benzoin condensation reaction, right? So here we go with the mechanism part. You can see here the cyanide ion that is being generated from the potassium cyanide, it will be acting as the nucleophile in the first step here. We all know that the carbonyl group here will be having a partial positive charge on the carbon atom because it is attached to some more electronegative oxygen atom, and obviously that will be having a partial negative charge here, right? So the first step will be what? That it will be the attack of the nucleophile on this electrophilic carbon atom here, sending the weak pi electrons onto the oxygen atom in this whole process, right? So that I can show you here, it will be resulting in the generation of this kind of intermediate in which now the oxygen will be having the negative charge. Now as soon as this intermediate is being formed here, it will be abstracting a proton from this carbon atom, I mean this one here, resulting in the generation of a carbon with a negative charge. We all know that this is known as a carbanionic type of species, right? Now there is present a strong driving force behind this particular step here, which I want to show you. We can say here that the carbon negative here is actually stabilized because it is being dispersed here because of two different kinds of effects. The first one is arising because of the electron withdrawing resonance effect of the cyanide group that is present in its vicinity, which you can see here. The negative charge is being shifting in between this carbon and carbon bond, and because of that the pi electrons in between the carbon and nitrogen, they are going on to this nitrogen, giving N negative here. Okay, so this is nothing but some sort of resonance stabilization is taking place here. Okay, and not only this, but also the negative charge is also dispersed in this way here because of the presence of a phenyl group in the vicinity. Once again, electron withdrawing resonance effect is taking place here, and whatever negative charge is present on the carbon atom, that is being dispersed in this way here, and I can write here that the resonance stabilization is taking place here because of the presence of the phenyl ring. Okay, so here is the overall picture. The negative charge is being stabilized by three different ways. The first two ways are we just try to understand on the previous slide, and there is also present a third possible way, and it is the presence of this oxygen atom. Because of that, what is happening is that it is withdrawing electrons with the help of an electron withdrawing inductive effect, right? So it is the combined effect of the electron withdrawing inductive effect of this oxygen, the electron withdrawing resonance effect of the phenyl ring, as well as the electron withdrawing resonance effect of this cyanide, that this negative charge here is being stabilized, right? So this is the main driving force behind this particular step here, right? I mean this step here, right? Now after that, as soon as this species is being formed here, it will be acting as a nucleophile here in this reaction, and because in the starting I have told you that the whole reaction is starting from two molecules of benzaldehyde. So here you can see that this is the second molecule of benzaldehyde, and once the nucleophile has been generated here, it will be attacking on this carbonyl carbon because it is having a partial positive charge and it is the main electrophilic site here, right? So I can show you the attack that is taking place now in this picture, that it will be attacking onto the carbonyl carbon, once again shifting the pi electrons onto the oxygen atom in this way, right? So moreover, it will also be resulting in the generation of a new carbon-carbon bond, because whenever some nucleophile attacks on some electrophilic species, it always generates a new carbon-carbon bond, which you can see here, right? So this is the new bond formation here that is taking place. Okay, now I am just reorienting this molecule or this structure here in this way, so that the next things can become easy here, right? So after that, let me erase everything else from here. So okay, before that, this oxygen negative will now be abstracting a proton from this position here, I mean this one here, and in doing so, these electrons which are in between the oxygen and the hydrogen, they will now be shifting in between the oxygen and the carbon, which you can see here, right? I mean in this way, the electrons will be shifting in between the oxygen and the carbon, and by this, the ultimate thing which will be happening here is the cyanide will be acting as the leaving group here, and it will be going out of the system, right? So we can see here, after this step, the oxygen negative, I mean this thing, will now become a hydroxyl group here, and the shifting of these electrons in between the oxygen and the carbon will be giving a carbon double bond oxygen, and the cyanide is going out of the main reaction here, right? Now, this is the main product molecule, which is benzoin, and whatever cyanide ion is being generated here, that will be attacking on the next molecule of benzaldehyde, because we are having a lot molecules of millions of molecules of benzaldehyde in the main reaction, right? So we can also say here that because it is regenerating here, so that is why it is not only the reagent in this reaction, but also it is acting as an active catalyst here, right? So let me correct this main slide here, where I have written that this is a reagent, but now after this mechanism, we are sure that it is not only a reagent, but also it is acting as the catalyst. Okay, so this is all about the benzoin condensation reaction, which is actually an important type of self-condensation as far as the aldehydes and ketone molecules are concerned. But do remember, it is not a type of some aldol condensation, because the main substrate here, it do not have any alpha type of hydrogen atoms, right? So this is it. Thank you so much.